Cool. Good. So what are we going to do today? We are going to fix these nasty bug, which is basically killing a node somewhere in here. So I was working on the simplify recursive thing. Here, it seems like we lose a qubit somewhere. Okay. So what am I doing here? So I have a dictionary M, and then I basically calculate the result, right? So what I'm doing is I'm iterating over each edge, and then each edge E1 and then E2, right? So a double loop here, a nested loop, and if E2 is not processed, right, because we don't want to repeat, like it's the same to take a look at E1, like sort of, H1 and 2 and H2 and 1, so we don't really care. There's probably a better way to do that, but I don't care now for the prototype. And then can we merge E1 and E2, so take a look at the number of differences. And what we do here is, okay, so this is a thing where I lose that for some reason. So here I need to check, I'm checking all the nodes in M E1. And what I'm doing is, and this is the qubit index, right? So I'm assuming so. So print n. And so we normalize the sum of the arrays of the H1 this node and H2 this node, and we put it into nodes this node. And if they're not equal, sorry, if they are not equal, up to phase difference, right? So I'll have to. So this is to do here. Okay, yeah. So global phase factors are important. But maybe I can design it in a way that this does not need to be considered, because all these global phase factors should be then applied to the to the amplitude of the branch, which it's still a big question mark for me. How do we implement all that? But yeah, but I mean that's the critical part, right? So, oh. This is the reason. This is the reason it's not working. Oh God. Okay, can this just not be that laggy, please, please? I need to take that out of here, and I'm sure we're not losing any qubit anymore. And that goes here. Basically, I was just, oh, jeez, that's so stupid. Cool. And now, yeah. Oh, not a number. Not a number. Interesting. Why? Why not a number? So I can, let's definitely print that. So merging, and then merging n, right? And then print these and print that. So let's take a look at what we're printing here, and then print. Okay. So we're merging these and that, and then it's just not a number. Okay, so the it looks like the normalization is not working. The function is not working as expected. result. One one. This should be normalized, right? And it's doesn't seem to be. Seems like it's breaking. So I had implemented that in the past. Like, how was I doing these? Am I not doing this here somewhere? No. Normalized complex array. What is this doing? So it's taking a minus the real minimum minus 1j origin offset it. I just wanna. So I just wanna. That's not. So I just wanna do. I just have to divide each component by the absolute value. So by the norm, right? Which is the square root of each component squared, right? So I think that's the way I was doing it. So I think I should just like say norm. So np array norm. I just want the is it called norm. Why is my laptop so slow? I don't know. I have to really sit down one day and work on this. It's not such a bad laptop. Array like. Okay, so lean alg dot norm. Lean alg dot norm of a. And then I can just divide that by the norm. Isn't that what you should actually get? Yeah. Okay, cool. Looks like that's cool. Yeah, that's what we want. Awesome. So let's yeah, that was easy. So now I can focus on, I have two things to, okay, let's first test, let's do a couple of more tests and see if we're happy with these. Okay. So here we have a, I don't want to print this. Oh, we can leave it there. So I'm doing a hardware gate, then I'm doing a control node and another control node which cancel each other. And so at the end I just should have a qubit in the plus state, Q0 is in the plus state, Q1 is in the zero state, which is exactly what I get here. What other examples we could use to test that? Let's see what happens with I don't know. I need to make one app. I mean, let me open Paint. Try to make one which is maybe a bit more complicated. So cool. Let me take that with me. There you go. Awesome. Am I painting or not? Yeah, of course, locked like hell. So we start with 0, 0. Then we can do yeah, bottom hard, right? So plus Jesus, plus 0. Then we do 0. Or we can do, so we can do the two hotmarts plus plus, and then we do control Z, right? And then we have a 0 plus and a 1 minus, and then mm, and then what if we do um, okay, so okay, so this is hotmart, and then control Z, right? And then what if we do a control Z or a control not like backwards? What should be the expected result? It should be that this is 0, 0, 1, 1, 0, 1, minus 1, 0. So, and here there's definitely some merging. We're not. There's no merging going on here. Yeah, there's merging going. Of course, there's merging going on. So this branch will merge with this one. So we would have a 0 and a plus, and this branch will merge with this one. And now there's phase kickback here involved. So I'm curious to see if that's going to work out at all, or because I'm not working with I haven't really worked with the amplitudes of the edges, so I believe this minus here should bubble up it should definitely bubble up in the amplitude of the sort of the whole edge. But because in theory, there should be a 1 minus, right? Let me double check with Quirk first. So the Quirk circuit would be, so the Quirk circuit, why is this going so slow? Why? I hate my laptop. So this is what we want, and now I want to do these, right? And so what do we end up with? So we end up with this system where if this is a 0, if I take a look at the 0 and put a plus here, I end up in the plus state. If I end up a 1, I end up in the minus state. That's exactly what we want here. Okay, cool. So how would I do this in here, right? So we can just comment that and say, good, we do a hotmart. So we do a hotmart on the 0 and a hotmart on QE1. Then we do a CZ. Do I have the CZ implemented? Yeah, I have it. Okay, cool. The CZ implemented. And then I do a CX backwards. And then that's it. And then I pen it. And then I simplify and I paint it. I don't have to simplify. Actually, if I don't simplify, let's see first if that gives me, this should give me this. So what is going on? What's going on here? So I have 4 edges. That's good. That's actually that's looking good. I have 4 edges, right? One is in the 0, 1. Another one is in the, well, I don't see them because they're really laid out in the worst possible way. So this is 1, 0. This is 0, 1. So we have these two here, right? But I don't see the minus. That's the problem. Because it's at the edge level. It's at the amplitude level. Okay, so that's probably going to be my next working example to work with the amplitude. Because I think, but I can't see these here. Isn't there a better way to lay these out? I thought there was a better way to lay these out, even from the HNX perspective. There's sort of the -1, the phase is here, I think, at the edge level. Here, there's two nodes, but I don't see one, and this is 0, 0. Okay, so but it seems like it seems like this makes sense. Let's see what happens if I simplify. Boom. Okay, that is definitely wrong. Yeah, and it's wrong because it didn't catch these. It's wrong because it didn't catch this. It thinks it's a plus, right? And so because I missed the phase, right? It's at the amplitude level, so I'm not considering it. Even in the merging, I'm not considering it, right? Which is what I should do. And exactly. And so it missed that, and it just thinks it's a plus. Because it thinks it's a plus, then it says, "Oh, I can merge that even farther, and I can say that's the same, and so this becomes a plus, and so you have a plus plus." So it's wrong, but I think I know why it's wrong, which is it's a good place to be in, I think. But that's definitely a good next example. Okay, so we need to work out how to operate with these. So there's two things to consider, right? So we're still just at the realm of so I need to work on these amplitudes at the edge level somehow in two different spots, because first is when you have when I apply gates, right, I can unconsciously add a phase. Like if I let me have another example here. If I just take these and comment on that, and if I take a system, right, and I apply the X gate to qubit 0, and then I apply the Z gate to qubit 0, all right, and I don't, I'm not going to simplify. So I have this minus in here, right? Now the problem is that if I have and this is inconsistent with the approach of applying a two gate, because when I apply a two gate, I programmed it in a way that these phases end up in the edge at the edge level. So if I say qubit 0 is in the Hadamard. Okay, so qubit 0 is in the 1 state, qubit 1 is in the plus state, and now I apply a 2 qubit gate. I apply a controlled Z. In a way that this should not, like this will just create a branch. What's gonna? Oh, because it hasn't been simplified, but why can I just not see that? Oh yeah, there you see the minus in here, right? I don't know if you can see this. Can you see that in OBS? So the thing is, the two branches have got now an amplitude that's attached to them, so I can rebuild the wave function, right? Because essentially what I'm saying is that whatever system, whatever subsystem, whatever system, whatever system whatever system this subsystem describes, it's got like a 50% chances of being in this or in this edge, right? But this one is negative. This is because of, yeah, and so that's the part that I'm. This is because of the control set that is flipping the. Um, mm, but wait a second, something is wrong here. So okay, but that's actually a. Oh, it's not a mistake. It's a correct thing. It's just that it doesn't simplify. Because I was thinking that should not create two branches, but it's well now node 3 and node 6 are the same. It's Q0 at both value 1. So if if we would simplify, I would like to see a minus, but I'm going to get a plus if I do that. Yeah, I'm getting a plus. And that is because, okay, so that's a simpler example to work with. So let's take a look at these. So so we've got the amplitude in here, right? And what I need to do when I merge is that I need to take the amplitudes down to the single element that is sort of the non-equal element. I absolutely don't know if this is something that makes sense or not, but it seems to be the only way. So when I'm simplifying, when I'm going through the recursive and I'm saying, can I merge stuff, right? Okay, so here's the where's the merging happening? Create edges, simplify recursive. That's what I wanted to go. Exactly. So yeah, this is the thing. Like I cannot just okay, I cannot. That's the problem. I cannot just add things blindly. What I can do is I can do it like this. I can say if they are not equal, I'm gonna take in the. Actually, no. I should do this with all of them, to be honest. No, should I? I should just pick one. Because essentially the amplitude that I have at the edge level, right? It's something that I want to add to each component of the wave function that edge is going to generate. So I cannot just every time I add two nodes consider them, because if I do so, I might not end up with the equivalent. Like it's like if I want to have a -1, right, like a phase in there, then I can add it 3 times, or I can add it like an odd amount of times, and that will still work. But I should just add it one, I think, as a one time as a basic, as just the way to do it, right? I guess I'm not explaining myself really well. I promise I'll do a deep dive on these. But what I should do is, if they are not equal, I'm going to assume that they are that I'm going to assume that this is the, it might be that it's the only one, and so I better account for that. So I better say I need to get the amplitude. How do I get the amplitude? Because else, so else just do this, but I need to add a multiplying factor, and the multiplying factor here is in the edges themselves. So what I need to do is I need to do probably something like So the EU amplitude, right? And I'm calling it amplitude, but E2 amplitude, but it's self edges E1. And now my question is, how do we call that? Amplitude. Yeah. Where am I? Amplitude. Which is a complex number. It's not an array, it's a complex number. So, but I think I can just say E1 amp times these, right? And E2 amplitude times that. I think that should actually make it. So if they're not equal, I take a look at the amplitudes and I'll just add them as factors. And to be honest, if they are the same, I don't have to add them. Why do I do that? I can just pick one, right? So I can just say, just get this one. Don't even normalize this, right? Because if they are different, I have to add them. Is this gonna work? I don't know. So did it work? Not exactly. Okay, so what happened? Oh, wait a second. It did actually. It did work, right? What did I do? So I do an X gate. I do a Hadamard gate. Yeah, it did. Of course it did. Nice. Okay, cool. It did work. I'm surprised myself of the fact that this actually works at all. So let's try with that example here. That was the one. So what we want to get is we want to have qubit 1 to have 0 and 1 and qubit 2 to have plus and minus. Oh, okay, cool. First error. That's nice. So what's the issue here? Key error. Oh, okay. Yeah, okay. Now it gets interesting, right? Because it's so this is the so it's yeah. And actually I knew that was gonna happen, so I'm happy that it's happening here. How do I know? So when I do the actual merging, yeah, no, to up here. So here, no, what am I doing? We merge these, do the recursive step. Exactly. But now we've basically created a new branch, right? And this branch doesn't have like, yeah, this thing does not have any amplitude. Because essentially it's a two-step thing, right? So, opa, let's go. Let's think this through, okay? Let's think this through. So the circuit that we have is we're starting with a 0, 0. Then we're doing a we're in the plus plus, okay? Then we're splitting these into 0 plus 1 minus. Cool. So we have, you know, whatever, and we have these like these amplitudes in here, which are taken from originally these being a plus. That's where I'm putting these amplitudes. Now, within each branch, okay, so now I think I gotta first work out how the amplitudes get properly set up in here at all, in the 2-qubit operation, right? So because what I'm doing is I get the local 2-qubit state vector, I apply the actual gate, and then I just, you know, I just get like a potential superposition, and so I just kind of create an edge for each, right? Yeah, and the amplitude is wrong if an edge exists. Exactly. That's the problem, is that now, right? So this is so I'm creating a new hyper edge, right? But the thing is, this will happen per per edge, right? I don't know how, but yeah, well, if they don't have an edge, then it's equal, right? So that also works for no edge, for the no edges case. But for the edge case, right? So I do that, and then I kind of, yeah, I have to create a new hyper edge, which basically my intuition tells me that, you know, what I have to do, right, is that if I got to multiply them somehow. So because now basically I'm going to apply a control x, but on qubit 1 being the control, and so this is gonna. So this is going to create a new edge. So I need to know what the parent amplitude is. Yeah, and so I probably need to, and then what I need to do is I need to create the I need to multiply it here because that's the amplitude. This here is the amplitude, I think, is it? Am I giving it the amplitude, or what am I giving it to the hyperedge? Yeah, the amplitude. So I need to keep track of the amplitude if that exists. So if not is a 1, and so what I do is I just multiply it, I think. Because then if this is like a half and I split like that into 2 more, then I'm going to get like a half of half and half of half. So I think, so the parent amplitude is basically, I'd say 1, right, by default. And so this is just a parent amplitude times this one. And if so, if this is an actual number, so if this doesn't equal none, right? Because that's, I think, what the initial state is none. It means that they are not. So if this is different than none, then parent amplitude equals self Okay, so wait a second. Oh, yeah, it's there's just one edge UID. Okay, so it doesn't matter which qubit I'm using here. So um, so self edges edge UID amplitude. So that's the amplitude exactly. Okay, cool. So I think that has been solved. I mean, let's see. Okay, so let's see if we can take a look at the amplitudes of the edges without simplifying. So if I don't simplify, I shouldn't get the error. I should just get the four things. Yeah, okay, that's correct because now I have 0.5, which 0.5 squared is like 0.25, and so it's a quarter. So that's correct. Cool. Now, how do I deal with these when um, simplifying? What do I do? So I'm simplifying. Should I divide or? I mean, let's take a simple case, right? Let's say I have the case of a 0 0 and then 0 1, right? Which they should be definitely merged, and I have like a 0.7 and a 0.7. So to be mathematically correct, that should be merged into a 0 plus with an amplitude of um, of 1, right? Because it's the only, and if it's 0 minus, if it's like something like this, which I don't know if it would be possible, then I probably should get -1, shouldn't I? Because it essentially means, so this essentially means that we have the following wave function, right? 0 0 0 1 square root of 2 square root of 2 and a minus, right? Which I can take that minus with me, the minus and the 0 with me. I can easily take. So I can easily just say minus what should it be really? I'm not so sure. So what should these be? It definitely must be 1. So I think I should just, yeah, okay, but I think that's basically, as I said, it's a division. I think if I'm multiplying, so the simplification it kind of feels like it makes sense for this to be a division, right? Because it would literally be 1 divided by the other. So, and if they're equal, and the question is in which order if they're not equal, right? Because that would definitely lead into no, it should always be 1. Why would it? Or should be, it should be added up and normalized. Mm. Mm. I mean, essentially, okay. So the thing is, you're expressing the same at the end of the day, right? I think that is not correct. Uh, I think that is not correct in the sense that in this case, because in this case, right, you're essentially saying, well, the system here is Yeah, well, of course. They go they go here. Yeah, that they go here. That's why you get a plus in the first place. And if you have just the system edge, there's no notion of this having any amplitude. And so it should just be a 1. But if for some reason I have another, say, 1 plus, I don't know if that would be even possible, right? Then these two merge, and so you end up with 0 plus. So these two merge, and this merging makes sense that it happens this way. The problem is when there's a third branch, or there's more branches, like well, then probably you just normalize. But over what? To be honest, I don't know. Let's try to stick to this example. So we have exactly. So now we have these, and now we expand each of them right into two branches. So you're going to have 0, 0, 1, 1 with a control node, right? 0, 1, right? And then 1, 0, but this one is going to have like, so these will all be like 0.5, 0.5, 0.5, and this is going to be minus 0.5, right? So we have these, and now we do the first. Now you do the first merging. So the question is, what do I do in between, right? So I take these, for example, these two merge, right? So and then these numbers go to the one that is different. So I'm then able to merge that and and be a 0 plus. Now I still have a 1, 1 and a 0, 1, which are 0.5 and then minus 0.5. But I have the feeling, because this aggregates two branches, it just should have the sum. Yeah, but the sum, okay, the sum normalized, or what? I think so. Because this is like 1, right? But 1 in the sense that it's 0.5 plus 0.5. And so I should still normalize that, which makes sense, because if I would ever have, say, no, but that's not, because then what happens with these two, right? Like, I cannot just say, like, it cannot be that it's 0, right? Because the 0.5 minus 0.5, if I add them up, they'll just be 0, and it's not, that doesn't make any sense. That doesn't make any sense. Hmm. I mean, it should be back to 1 over the square root of 2 and 1 over the square root of 2. That's it, really. 1 over the square root of 2 and 1 over the square root of 2. So something tells me that division is sort of the right step forward, but because of the sign, I'm just not comfortable with these. And there's theoretically anyway this in between step where these amplitude. So the problem is this amplitude is not yet there existing. So it's sort of a temporal edge that I'm creating here. And I'm creating this temporal edge, right, which does not exist. So I'm not storing the amplitude anywhere. That's why actually it breaks, right? Because then there's no amplitude. So temporal edge and has no amplitude. Solve this. Yeah. Cool. I think I'll just leave it here. I have to think about these, and yeah. But once I figure this out, I think I'll be almost ready, because once I figure this out, the only other problem that I have left to do, I mean, obviously apart from implementing expansion, which I don't know if I will not leave it for later, I need to make sure that this works for cases where we have bigger, so more qubits. And so, what happens if we're targeting 2 qubits within an edge that have more qubits and more qubits entangled? That is, I think, a case that is not covered in here. What if more qubits? Oh, but it's yeah, okay. What if more qubits entangled? Yeah, no, sorry. That's like that's the two biggest conceptual to-dos, I think, that I have. If I figure this out, I think I'm done. At least with the first iteration. With we've got to simplify, we've got like the basic operations, and I'm just not happy with the way of rendering that, because it makes it complicated to be able to see everything. So I might try the other. There's another visualization for these, I think, in HNX, or maybe find another library. But I'm quite happy with the simplification. I think that is a good algorithm. And then so this is, where am I taking this from? I think that just works by miracle. So I have the edge. Yeah, okay, so these should be, self edges E amplitude, right? But this might not exist always. Okay. Okay, we'll see. Cool. I'll just leave it here, I think. So I got to figure out. So the next step is for me to figure out what do I do with the amplitude as I merge, sort of the temporal amplitudes, and how to make sure the create edges then works correctly and reflects the correct amplitudes at the edge level. And then we can go and approach the apply 2-qubit operations. And I think, and I also got to fix these, because if I apply a single qubit gate in an entangled pair, then the global phase should really apply it should really apply at the amplitude level. I should really treat which, if there's no entanglement, it makes no sense, because system is not. So this is another to-do. Manipulate amplitude if qubit is entangled. I think that's the other big pain. Awesome. I'll leave it here. Goodbye.